Welcome to the lesson on 14.2, choosing between linear, quadratic, and exponential models. And we'll be using a regression feature in your TI-84 today, so make sure you have your graphing calculator with you when you're watching this video. So let's talk about the rule of thumb for visually choosing a model. If it's a linear equation, the trend tends to be either going roughly in a line, either going up or down. So this is an example of skin cancer mortality versus the state latitude. Looks like as you go further up north, the skin cancer goes down. And this one here is the comparison between the average of husband's age. Comparison between the wife's age and a husband's age. It forms to have a straight line, and there seems to be a relationship between that as well. The quadratic is it could go up and down, but this is a nonlinear model that we have here. We got two. One is quadratic, the other is exponential. This one, a quadratic, tends to have something that's like turning point right there, guys, right? And this one over here, it doesn't show the turning point, but the bottom side, it doesn't seem to settle down to a value like this, right? So I would go with quadratic on this one. Sometimes it's hard to tell, but anytime there's like appears to be a curvature like this, turning point, or it doesn't seem to be settling down like this, but rather it will turn up somewhere. So I would go with quadratic on this one. So what is exponential? The data trend flat then swings up, right? Or data trends flat then swings down. So in this case, it's fairly flat and then goes up. And that was population in Davis County in Utah. And in this particular one was a carbon footprint as the city miles per hour, the fuel efficiency, right? Now, this could have been interpreted if you had up to this value to maybe a quadratic, but common sense tells you that it's not going to turn up. And also, the last two values over here seems to be settling, right? And if you think about this, guys, no matter how good your miles per gallon is, generally speaking, cars that are efficient would tend to have less, and it's not going to all of a sudden have more later, right? So you sort of have to be aware of the kind of information you're dealing with as well. Okay, so let's move on to this. This is a little tricky, right? Let's look at number one. That looks to be going down. All of them are going down, but this appears to be pretty straight, right? Yeah, if you draw a line there, it really should have about the same number on either side, or the distance between each point and to this line should be minimized, right? So it appears to be linear with a negative slope. If you look at B though, if I draw a straight line, it doesn't look right, right? There seems to be a bit of a curve over here. So I'm going to say that's quadratic with negative leading coefficient, meaning A is negative. And in this particular one, it seems to be sort of like settling down this way, to my eyes. Anyway, so I'm going to say that it's exponential with B between 0 and 1, meaning it's exponential decay, right? Now, indeed, the major difference between these two is actually this value right here, the last one. So at C, this convinced me to go with exponential, but here the last value sort of popped up again. So that's convincing me that it probably should be a quadratic because it's turning around. So it's a quadratic with a positive leading coefficient, so A has to be positive. Okay? All right, guys. So let's actually do an example from your book. So we're going to be doing linear modeling, modeling that has a linear function. And we're going to choose a data set from the set that you see in your book, okay? And the notes that I gave to you. And then number two, using our graphing calculator, we're going to create a list, create a scatter plot, and then we're going to perform a linear regression. And I will put a link to how to do a scatter plot, which we did in class, and I'll also do a little bit of a linear regression in this video as well. Okay. And also, we need to graph the model next to the scatter plot and assess how well it fits. Okay, here we go. So we got wildlife conservation data sets and scatter plots for the population over time of 4 endangered or threatened or scarce species as shown here. So which one of these do you think best fits the linear model? Well, I think it's this one, isn't it? I mean, it's pretty straight, so let's go with that one. And step 2 will be we'll be doing the scatter plot, generate the linear regression, and number 3 we will compare the graph and scatter plots. So number 1, we went with bald eagle pairs. It looks pretty straight to me. The increase that we see here is pretty constant. It's pretty steady, isn't it? It's not rising or it's not decreasing the rate at which it's increasing or decreasing. So that's the hallmark of linear model. So what is y-intercept? Well, we have a bit of an issue with this, but as far as I could see, it's about 3,000-ish, right here. And slope, it's generally from here to here, and I just basically took the largest value of the y, the last point and the first point, and I found the slope using that. It was around 340. So I guess we could say the y is about 340x plus 3,000. But when you look at it very, very carefully, when you draw a linear line, there should be about equal number to the left or to the right, or above or below. See, that's a little bit below. This one's slightly above, and this is slightly above, and so forth. But if you look over here, it looks to be a little bit more than 3,000, and I'm not so sure that this is 340 exactly. So what we're going to do is you're going to use a scatter plot to find this. When you're doing this, we need to enter a scatter plot, but as you could see, the years since 1990, so this really should be 0. So you should enter the 03095, that's 1. The last term should be 10, 641. So when I enter that into the calculator, this is what I had. And when I put the graphing and did the scatter plot and then found the linear equation to be this, right? It came out to 338.2x plus 3042.7. It's fairly close, but slightly different, right? So let me show you how to do that right now. So I've entered the values already for you guys. So when you do that is you go to stat, and edit, number 1. I believe, if I'm not mistaken, I put those values on list 3 and list 4. So make sure you enter those values, and if you need to do so, pause the video. But I'm moving on. So how do you graph this thing? So I want to graph the scatter plot. It would be second stat plot, and I've already made one over here, 3, 4. But you have to look at the values. You have to look at the values of the list, and the list turns out to be the y value goes from 3,000 to a little less than 7,000. The x value goes from 0 to 10. So they'll inform me how to graph this. So anyways, I turned that on. That's good. And I also need to go to the y is equal to, and I need to find that. But how did I do that? Okay. So what you do is you go to stat and you want to calculate. Because it is a linear regression, you want to choose number 4 right here. You could choose 8, but 4 is closer. So type in 4. And that was, it had the list, I believe, in 3 and 4, right? So X list has to be drawn from list 3, and then Y list has to be drawn from L4. And we're going to scroll down and calculate it, enter. And A represents the slope, and B represents the y-intercept, right? So 338.2 versus 342.7. So I typed that in already, as you could see over here. So when you go here, be sure to type that in, and I did that. And I'm going to hide this one, the y1, y2, and y3. I went ahead and did that already for you guys. Hold on. if it's not darkened, the graph is not going to show. So let's go to the window. So I know that okay, so I made the window negative to 11 to encompass all the x values and then some more on either side, on the left and the right. Same thing with my y value. Whatever is my minimum and whatever is my maximum, I tend to add to that, but I also like to see the x-axis. So I put a negative 500 here. So let's trace it. And that's the graph that I see right there, guys. Okay. So all those dots represent all the values that we had. So as you scroll to the right, you can see all the values, right? It was 5, 4, 7, 1, 2, 6, 5, 0, 9, 4, all the way to the last value, which is 10 years afterwards. You will have 6,471. If you scroll up, and you'll see the equation that's drawn here. So this appears to be a very, very good fit. So here, as you can see, there's a screenshot of the data values that we see, and we can conclude that graph, indeed, equation that we found, was a very good indicator of the actual data set. Moving on to the modeling with quadratic function, we need to find the best data set that appears to be quadratic, and we need to explain why it is. And then step 2 and 3 is the same. Okay, and in this case though, we need to do perform quadratic regression, not the linear. Okay. All right, looking at this, this is linear. Now, this, I have no idea what this looks like. There appears to be two clumps over here. If I had to decide what it is, it might be maybe quadratic, negative quadratic, except these two values create a clump over here. So I'm not convinced that's the best choice. Now, this appears to be flat over here, and then it increases. It looks very exponential to me. So I'm going to go with Florida's manatee population. So I chose the Florida's manatee population because it's nonlinear, first of all, and it has a turning point. It appears to be coming down and up. And it doesn't settle, right? It looks like a quadratic with a greater than 0. And step number 2, I'm going to type all those in, and be careful, guys. This went from 4, 5, and there's no 6 or 7. It went to 8th year, right? So step 3, when I graphed it, I took a screenshot. It looks just like this. It was 44.8x squared minus 275.5x plus 3360. And it appears to be a pretty good fit. Okay, so I'm going to show you how I did it through a calculator, and I probably won't talk as much. And I stored the data value in L5 and L6. So when I go to step plot, I'm going to turn this one off. And I'm going to turn the second plot. And my X list is L5, my Y list is L6. So I'm going to quit. When I go to Y is equal to, I've already performed that, but let me show you how I got that. First, you go to Stat, you go to Calculate, and there's a quadratic regression right here, number 5. And we drew that from L5 and L6, so I gotta type that in. L5. And Y list we draw from L6. And we scroll down to Calculate. Boom. Here we go. My X is 44.8, B is a negative 275.5, and C is 3366.0. So that's what I typed in over here, guys. Okay. So now the values are a little bit different, so I have to work with my windows, right? my values here go from, let's look at the list first. Oopsie. Stat. Edit. Because I know my list is in 5 and 6. So x goes from 0 to 10. Y goes up to, that's about 6,000, right? So I go to the window. I like to be around 6,000. 6,000. And my x value I think is okay. So I'm going to trace it. Oops, what happened? I see. I forgot to undo the y1 and activate the y2. So let me do that right now. So I go hover over the equal sign, press enter. You should white it, and then I go hover over the equal sign of the y2. I click it, and it has been highlighted. So now I trace. There you go. And right now the values indicated of x is 0 and y is 3, 3, 0, 0. If I keep scrolling to the right, it tells you all the values. And if you scroll up, it gives the equation of the curve, and it looks to be a very good fit. Okay guys, so that's how you use your calculator. So we got one more left. Now we'll be dealing with exponential function. In this case, it's an exponential function right here, right? And step 2 and 3 are exactly the same. So here you go. Which data set appears to be the best model by quadratic equation? Okay, that's a typo. This should say exponential. And I think we're going with the TX whopping crane population. That is because it's nonlinear, number one, and appears to have a horizontal asymptote down here. It seems to be settling fairly flat at the beginning and then turns up. Okay, step 2, I gotta put in all the data value. Oh, sorry, because it's a growth, it's an exponential curve with b is greater than 1. So you sort of need to expect that. Step 2, I typed in all the values, 0, 22, all the way to 70 to 81. That's years since 1940. And when I went through all that, here's a screenshot of what I got. This is what I got right here. And it looks like a very good fit. My equation was 20.1 times 1.037 to the x. So basically what that means is that each year the population seems to be growing at 3.7%. The 1 represents the original amount plus the 0.037, which is 3.7%. All right, let me show you how I did it on a calculator as well. Here we go. I'm going to change my y value. I'm going to activate y3 and undo that one. And I'm going to go to step plot and deactivate the second one and activate the third one. I believe I put that in list 1, 2. Okay, now I actually have to show you how to find the value. So you go to stat and calculate. If you scroll all the way down past ln regression, natural log regression, here we go, 0. That's what it is. Exponential regression, type in 0. And I drew that from, I believe, it was 5 and 6. No, it's L1 and L2, right? X list from L1 and Y list from L2. I calculate. There you go. And it gives me 20.05, so I rounded to 20.1. And that was 1.0374. I just put it as a 1.037. Okay, and we'll talk more about how to choose those values more carefully. Okay, now that I typed that in already into your y3, let's trace. Okay, looks like I made a bit of a mistake. Can you tell me what that is? Yeah, it's the window. It's essentially the window, right? So let's go to the window. We are on the list L1 and L2, I believe, if I'm not mistaken. My x value is from 0 to 70, and my y value maximum is 281. So what I want to do is, it was maybe -5 would be good. It was the 70, so let's go maybe 90 every 10 years. Otherwise, you're going to see a lot of tick marks every 1 year, right? And I believe the y value, the maximum value was what? 281. So maybe 350 every 50. And I want my minimum to be -50. Okay, let's trace it out now. Once again, you could right scroll and find all the values, as you can see right there. On your calculator, you're going to see right there, right? I have the added advantage of having it this big. Sorry, I should have made that screen a lot bigger. And I could just scroll to my values, or I could just up scroll and find the equation right there. Right here, guys. All right, that's how you use your calculator. And I believe I am done with this lesson today. So I will do all the B examples when we're in class. Okay. Be sure to bring your TI graphing calculator. Have a good night.